In this video, I'm going to show you how to work with RT ToolBox 2 to program a Mitsubishi robotic arm. We're going to go through the general use of the software as well as create a simple program. I'll show you how to connect with the virtual controller and operate the program in there, as well as show you how to work with a real-world controller and connect it to the software. Let's get started. First, open your RT ToolBox 2 software. You can do this either from the Start menu or from clicking the icon on the desktop. Next, we're going to create a workspace. The workspace is a place to put all of your programs, settings, and various configurations for the robot that you're working on. We'll create the new workspace by clicking on this new workspace icon here. I'm going to save my workspace to my network drive. And I'm going to call this Robot Labs. You can add a title name if you wish. I'm going to leave mine blank. The next thing we need to do is define the project name. I'm going to keep my project name as the name that we have called our robot here in the lab. The robot I'm working on is Gort. The controller that we're using is the CRN 500 series. We're connecting via RS-232. In order to set up the serial port, you click on Detail. Pull down the COM port that you're using. In our case, it's going to be port number 6. The data transfer rate that we're working with is 19200. 8 characters, no parity, 1 stop bit, and we're using the non-procedural protocol. Say OK to accept these settings. Next, we'll select the model. Because I know mine is the RV-2AJ, I'm just going to type in RV-2AJ here. You could also pick on Select and pick from a list. If you need to change the type of language that you're working with, you can pull down this list here. In this case, we can see that the RV-2AJ will support both MoveMaster, which is the older legacy language, and Melfa Basic 4. We are not using an additional axis, so we will turn off that option and say OK to create the project. When it comes down to working with the RT ToolBox software, we have a couple of buttons up here across the top. We have the ability to add a project. We can connect with the online robot, or we can run the simulation. To start off with, we're going to create an offline program. In order to do this, we'll navigate over to the workspace on the left-hand side here. Select the Expand button next to Offline. Select Program, right-click, and say New Program. Now, when creating a program name, it's important to keep in mind that this will be displayed on a 7-segment display. This means that some characters may not show up correctly. In my case, I'm going to call this PRG1 for Program 1. Say OK to create your program. Now we have a blank program screen. When it comes to writing a program, it's always best to create a description or a title block for the program. In my case, I'm going to use a program name, author name, and the date that the program's created. In order to put this information in, we have to add them as comments. The way that we comment our code is by adding an apostrophe. In order to make this easily visible, I'll also add a line of stars and an extra line of comment below. This makes a nice program header and is easy to edit and easy to see any important information about the program that we've written. The program that we're about to write is a simple program. We're going to use 3 positions called pwait, pget, and pput. You'll notice that every position that I mentioned started with the letter P. The reason for this is that the MelSoft software actually requires P to be the very first character in every position variable defined. We're going to be using a few new commands here during this video. The first command is move, or MOV. This tells the robot to move in the most efficient method possible from one point to another. This could be an arc, it could be an S shape, it's whatever works best for the robot. We'll also be using move straight, which is represented with MVS. This tells the robot to move in a perfectly straight line from the last position it was in to the position that we're specifying. We will also be using the hopen and hclose command in order to open and close the hand. And lastly, the dly command, which adds a delay in seconds. Now let's get on to writing the code. First thing we're going to do is move to our wait position. This is simply represented by typing move pwait. Then we'll move to pget. Now, because we're going to be picking up a part by the time we're done this program, we don't actually want to move directly to get, otherwise we would knock the part over. Instead, we want to move above the part. The way that we do this is by using a Z offset. By placing a comma and a value, we can offset in the Z direction. In this case, we're going to go -20. This is 20 millimeters above our pget point. Then, because we don't want the robot to move in any kind of an arc when we go down to actually pick up our part, we're going to add a move straight. At this point, hopefully our hand is already open, so we can tell our hand to close. The reason we use hclose space 1 is so that we specify the first hand on the robot, as this robot has the ability to have 2 hands, and we're telling that hand to close. Now, because robots are designed for speed, they read a couple of lines ahead of what they're actually doing. This means that if we didn't add a delay at this point, forcing the robot to stop for 1 second, it would actually start moving before the pneumatics have a chance to actually close the gripper. Once we have the part in hand, we can move above and move to our pput position. And of course, we'll move above pput because we want to be able to be above the point, then put the part down, and then open the gripper. Lastly, we'll move above pput again. Back to pwait. And then, of course, at the end of every program, we have to add the end command. This tells the robot that this is the end of the code. Now at this point, if you'd like, you can actually go ahead and hit this button here, syntax check, to verify your code and find out if you've made any errors. When I hit this, you'll notice we get a lot of errors. Actually, in fact, every error or every line of code that we've written has an error saying that there is not a line number. In order to fix this, we can go to Tool, Renumber, select All, pick your starting line number. I'm going to pick 100, and enter your line pitch. What this does is this allows us to start at line 100 and increment in tens all the way down the row. The reason you might want to increment in tens is so that if you do forget to add a line, you can actually put a line in between other lines and correct that, and then just go back and renumber it later. It'll ask for confirmation, and now we have all of our lines numbered. Let's click on syntax check again and see if we have any other problems. Now we have 0 syntax errors. Although I do see one myself, which is that there's no space right here between the minus and the comma. Sometimes that will work, sometimes it won't. My recommendation is verify that there's a space there. Do another syntax check to make sure I haven't made any other errors. And our program's now good to go. The next step is to add these points. Right now, we've created 3 points in our program, but the robot has no idea what these points are or where they're located. So let's add those points. By clicking Add, we can type our names for each of our points. And we have our 3 points, all as zeros to start off with here. Now at this point, we need to connect either to the real world robot or to our simulation, as we're going to do right now. In order to start the simulator, we're going to click on this light blue lightning bolt. This is going to start up the simulation. It may take a moment depending on what machine you're on. And you'll notice when we start up the simulation, we end up with 2 new windows that open up. Number 1, we have the front panel. And number 2, we have our simulated robot. In order to make these points operate, we're going to jog our robot to our desired position. In order to do this in simulation, you click on Jog. I'm going to put this into XYZ coordinate mode. This will allow me to move through the Cartesian coordinates. And to start off with, we're going to move down and forward. And down a little bit more. In fact, I think I'm going to go up a little bit to about 370 in my Z to give me my weight position. Next, to add your position, we can double click on weight, say get current position, and it's going to load the position from our simulated controller. Next, we'll move down. Keep in mind, I'm doing this in very small increments for a reason. I will show this to you when it comes to actually putting this into the real world robot. This will be our pget. And our pput. Now that we've loaded all of these positions in place, we can go out of jog mode, close our program and our simulator, click offline, close out of our program, and we'll say yes, we want to save our changes. Now if we expand that offline and expand program, you'll see the program that we've created. In order to get this into the simulation or into the real-world robot, the procedure is the same. Let's start with the simulation. First, we're going to click on Simulation to turn on our simulator again. Once our simulator has started, we get this online option that shows up in our workspace. We can expand this and click on Program. You notice right now, nothing shows up under Program. There's no programs in the simulator. We can now right-click, go to Program Manager, and when the Program Manager screen opens up, you'll notice both are currently set to robot. This is trying to move from the robot to the robot. That's not what we want to do. We want to move from our project to the robot. So we'll click on Project under the source, select the program, and we're going to copy the program over to the simulator. If you use the move function, what will happen is you'll actually move the entire program from your project into the robot, and you won't have the ability to edit it anymore. Now, at this point, we can tell it to close. To start our program, we can hit this select on the simulator, select the program that we want to run, and now our program is up and ready to go. You'll notice that the servos are on. At this point, we can hit start in order to run our robot through its operation. At any point during the operation, we can press stop to stop the program. We can hit reset to go back to the beginning. If we allow the program to continue, it will simply repeat the code over and over again. When we want it to stop at the end of the program, we simply hit the end button. The light will flash, and the program will run until the program has ended. At this point, we can turn off the servos and close out of the simulator by selecting offline. Next, I would like to show you how to put this program into a real-world robot. We've already gone through and set up the serial port. In order to connect to the robot, we will select this dark blue icon. This may take a moment, as when your robot connects, it will actually bring in all the programs that exist in your robot. Once we've connected and have gone online, you'll see this online copy of the robot. However, you won't see a simulation window because we're not using a simulation. When we expand online, you'll see a whole bunch of options here. We're concerned with program. Again, we're going to right-click on program, go to Program Manager, and we're going to copy our program to the robot. Then select Close. The next stage of this operation is going to be to test the robot program. In order to do this, we're going to expand Program to find our program that we would like to test. Select it, right-click, and say Debug. Now, before you press Debug, there's a couple of things you have to make sure on your individual robot. Number one, you need to be sure that there is no one in the robot work cell, because at this point, the robot can and will move. The door must be closed, the teach pendant must have the key switch in disable, and the key switch on the front of the robot must be in auto external. At this point, it's also good to make sure that you have the teach pendant in your hand or very close to you so that you can actually stop the robot with the e-stop should something go astray. Next, we'll click Debug Open. tell it to read everything. And you get this warning. This warning is telling you, make sure that you have that teach pendant in your hands because the robot could move without warning, and you want to be able to e-stop the robot before it possibly crashes into anything or hurts anyone else. Now we see our program with the pointer at the position that the program is at, and we see another representation of the front panel buttons for our robot. Once we're connected to the robot, making sure that you still have the teach pendant close, it's best to make sure that the speed is running very slowly so that if something does go wrong, it's easy for you to fix. So the way we're going to do this is we're going to grab this override and bring the speed down to 10%. We'll reset our program to make sure that it's going to start at the beginning, as illustrated by this program pointer being up here at the top. Next, we can turn on the servos. When we turn on the servos, it's important to note that this is going to turn on at the robot as well, because we are now working with the real-world robot. Software will execute one line of code every time we press this forward button. I'm going to press the forward button up until I get to line 180. At this point, our robot could potentially move, so you need to be watching the robot while you press the button, ensuring that it will not collide with anything in its motions. Now we're at position P wait. Moving to P get or above P get. 2P get. Closing the gripper. Waiting 1 second. Above P get. Here's that move command, MOV. Notice how it moves in an arc. To above P put. Down to P put. Open the gripper. Wait 1 second. Above P put. And back to P wait. Now that we've seen it run through the program and we've realized that it's not going to collide with anything, we can hit the reset button to put the program at the beginning, hit continuous to watch it run the entire thing through once at 10% speed. Again, making sure to keep our hand over that e-stop button in case it decides to go astray. When we're done, we can press servo off, hit reset to go back to the beginning, and we can close out of debugging mode by closing our program and then closing the controller. If we want to make an edit to the program online, such as reteaching our 2 points, P get and P put, so that they're over top of the table, we can simply double click on our program Jog the robot to its given position, click on P-Put, and hit Get Current Position from the robot to pull the position from the actual robot. Once everything's done, don't forget to go back to your offline program using Program Manager and copy from the robot to your project. Overwriting the program that's in your project already to make sure that you have the most up-to-date program. That's it for this tutorial. Now your challenge is to write a program to pick up from pget, place the puck at P-Put, then pick it up from P-Put and put it back to pget. I've shown you how to program half of it. Now it's your task to program the rest and demonstrate to your instructor.